Hi students, welcome to Preliminary Chemistry and Metals video number 9 in this series. In this video we're going to have a little bit of a look at the relationship between the activity of metals and their position in the periodic table. So you've now carried out some experiments to look at some of the different reactions involving metals. We know that some metals are more reactive than others. They react more spontaneously or at lower temperatures or with less concentrated solutions of acids. So we can get a sense of how active certain types of metals are. We can also have a look at the periodic table and see if there's a relationship between the activity series of metals and their position in the periodic table. When we do this, we find a couple of things. Firstly, the group 1 metals are the most reactive. So those ones on the extreme left of the periodic table going down, these are the most reactive metals. They're group 1 metals. Right next to them are the group 2 metals, the alkaline earth metals, and they too are active metals, high in reactivity, though not as high as the group 1 metals. The other thing that we notice is that as we go down each of the groups, they become more reactive or more active. There's a couple of reasons why that's the case, and one of those we'll look at later in this slide and in following later in this video and also in subsequent video. After the group 2 metals, then it starts to become a little bit harder to see the patterns. We have group 3 elements like aluminium. We have some transition metals like zinc and iron. Then we move on to group 4 metals like lead, and finally onto some more transitions such as copper or silver or gold. So these are, I guess, a general order of how we can find the most reactive metals in the periodic table and whereabouts the more or less active metals sit. Now, these are kind of trend positions. They're not fixed, and it's very difficult to just look at the periodic table and automatically go, well, these ones here are going to be the most reactive and these ones are going to be the least reactive. We can do that for these two groups. Certainly, there's some very clear patterns that emerge for both the group 1 and the group 2 metals, but it gets a little bit more complicated after that. As I mentioned, there's a few other things that we can use the periodic table to help us do. The first thing is that whilst over on the left of the periodic table are the most reactive metals, we know that going down the groups are also going to be more reactive metals. So even if we look at group 1, which we already know is a group of very active metals, we can have lithium, we can have sodium, we can have potassium, we can have rubidium. And these are, as we go down this table, are becoming more active. And of course, francium is at the bottom. The other thing that's important, and we'll have a look at this in a separate video, is the strong link between reactivity and something called the first ionization energy. Now, ionization energy is about creating an ion. Specifically, it's about removing an electron and how easy that is to do. And if we think about something like sodium, a sodium atom, which is neutral, has no overall charge, can become a sodium ion by losing an electron in a process that we've now described as oxidation. Oxidation is loss of electrons. The amount of energy required to remove that electron from a stable sodium atom is referred to as the ionization energy. And the first ionization energy refers to the fact that we're taking one electron away. We'll look at this in the next video in a little more detail, but the important thing at this stage is that the reactivity of metals increases as their first ionization energy decreases. That is, the easier it is to remove that electron, the more reactive the metal. Thanks for watching.